So we looked at polar primary production, and we said it's limited by light, not nutrients, because the ocean is well mixed throughout the year. It always has high nutrients, being primary production, recycled, remineralized, well mixed. So as soon as light becomes available, you get a massive production. You would think that tropical oceans always have light throughout the year, so they must be very productive. We'll see that actually tropical oceans are among the least productive oceans. Why? Because even though there is light, because there is so much heating in the tropics, the thermocline is very strong. So other than the regions where upwelling happens and forces the nutrients into the euphoric zone, most of the tropics actually have stratification that's so strong that it's hard to mix up the nutrients into the surface. Okay, so you can see here that the temperature profile being shown, very warm waters near the surface, they are nutrient depleted. Remember the nutrient profile, low at the surface, higher at below the surface, right? You have very strong thermocline. The stronger the thermocline, the harder it is to mix up, because you need the energy to convert the heavy cold water into the surface water to mix it up. So you need the wind energy, and the heating makes it worse because the heating makes the thermocline stronger. Heating makes the surface warmer, thermocline stronger, so makes mixing harder, right? So lack of nutrients. Unlike the polar regions where there are always nutrients, but light is a limitation, in the tropics, light is not a limitation, but nutrients are the limitations. But there are high primary productivity regions of the equatorial upwelling, coastal upwelling, and coral reefs. Remember, we looked at the table of primary production. Equatorial upwelling region is productive, but not as productive as coastal regions or higher latitudes, algae beds and so on. Okay, coral reefs, these are coral polyps, are animals that grow. They need oxygen and food, and so they begin to support zooxanthellae, which are symbiotic algae attached to the polyps, coral polyps. Coral is basically building a structure. It's using calcium carbonate, staying close to the surface where there is enough water, and it's providing a home, right? So it's a very effective recycling system. We'll look at corals a little bit more later on. So warm waters of the ocean is where you typically find corals, right? When you go diving in the Great Barrier Reef or the Lakshadweep and Andaman Nicobar and so on, they're warm waters. Warm waters don't have upwelling, nutrient poor, but corals are like the rainforest of the ocean. They have a lot of recycling. Zooxanthellae, they use up CO2 being breathed out by the heterotrophs and doing photosynthesis, and it's releasing oxygen for the corals and other animals that live there, right? So it's a very good recycling symbiotic system. You get huge biodiversity and so on. So symbiotic algae live there. They recycle nutrients very efficiently, and if you look at the primary production later on, I will do the temperate ocean separately because it's got some very interesting seasonality that must be understood properly. Okay, so just remember that the short podcast about the tropical ocean primary productivity is that light is not a limitation, nutrients are a limitation. But there is another point we should add here that relates to global warming. Let's say global warming is happening and the atmosphere is getting warmer. What would happen to the ocean? Ocean surface would begin to get warmer. As we will see later on, ocean surface is getting warm in most places. Dynamics, because the winds also change, ocean circulation changes, so upwelling region doesn't necessarily warm as much as the non-upwelling region. So the patterns of warming can be complicated, but nonetheless ocean surface warms because of global warming. What does that mean? That means the thermocline gets stronger. What does that mean? That means primary production can become less because of global warming. right? And there is some evidence that overall primary production is decreasing because of global warming. Okay, so now you remember, thermocline is the sharp gradient between the warm surface waters and the colder ocean, and the thermocline gets steeper with global warming, which can be prohibitive for primary production. Okay, there are other details. There may be other species that compete better. For example, directly take nitrogen in the surface waters and do what is called nitrogen fixation. So instead of using NO3 or ammonium, they will directly use N2 by indirectly converting it into nitrate and so on. So there are what are called diazotrophs like trichodesmium, which can do nitrogen fixation. So tropical regions are serving as indicators for how ocean primary productivity will change with global warming. Okay, so we'll look at the temperate ocean in more detail, where we beautifully combine the physics, seasonality, and the timing of the blooms. Okay, see you there.